Welcome back to We Rock in Math with Miss Catherine. In the previous video, we talked about rational numbers. If you haven't watched the video yet, there's a link to the video in the corner up above. So if you haven't watched that video, you can go ahead and click on that video if you need to have a refresher on what rational numbers are. But today we're going to just talk a little bit about irrational numbers, since we didn't get to it in the previous video. And then we're going to go through some examples together and determine whether each one is a rational number or an irrational number. So let's start off by talking about what an irrational number is. So as a review, a rational number is any integer, fraction, terminating decimal, or repeating decimal. And you can watch the other video on rational numbers to get more details about what is considered a rational number. So this is the definition for a rational number. And an irrational number is basically anything that is outside of those categories. It's any number that cannot be written as a fraction. So, looking at the first example, 2 over 5. If you're familiar with turning fractions into decimals, you'll see that this 2 over 5 fraction can be converted into the decimal 0.4. I find it easier to convert the fraction into a decimal just to make sure that when you convert it, it does end up being either a terminating decimal or a repeating decimal. So here we have a terminating decimal. So we know that this would be a rational number. So we're just going to write rational. All right. Then let's look at our second example. So our second example, we have pi. If you're not familiar with what pi equals to, if you have a calculator, you can just type out pi and you should be able to get the result. And pi is always 3.14 in the beginning, and then we have a couple of other digits in the back. So after that we have 1, 5, 9, 2, 6, 5, 3, 5, 9. I'll just stop there and we have some other ones. So if we look at this pi number, we can see that the digits, and it's not a terminating decimal or a repeating decimal. So that would mean that pi is an irrational number. So here we write irrational. Let's look at our third example. So for this example, we have 1 and 472 thousandths. We see that this number here, it's not repeating, but it is a terminating decimal since 2 is our last digit in the thousandths place. So that means it's a rational number. So we're just going to write rational here. Let's look at our next example. We have 264. So this number is an integer, and it's also a whole number. But since it fits the description of an integer, this is going to be a rational number. Let's go to our next one. We have the square root of 2. The square root of 2 is equal to the decimal 1.4142135 6, and there's some other digits after that. So for this one, we see that this decimal is not considered to be a terminating decimal or a repeating decimal. So since it doesn't fit those two descriptions, that means it's an irrational number because we don't have a decimal that is repeating, where the digits are repeating, or a decimal that's terminating. So that means that it's an irrational number. So we want to write irrational. And our very last one, we have 0.33333. And again, from the previous video, if you watched it, this is the same as if you had 0.3 with a repeating bar line on top. So these two are representing the same number. Now let's see. Well, this number is in fact a repeating decimal. So that means this number is rational. Alright, so hopefully at this point, now you have a better understanding of rational and irrational numbers. If you like this video and thought it was helpful, please like, subscribe, and comment down below if there's a specific topic you'd like me to do. Until then, see you next time. Thanks everyone.